our recipe for calculating the Haar measure of a compact Lie group starts by saying expand this object here, g of x, that was g in some parameterization, x here, so I suppressed the coordinate map, g of x inverse, and then the partial derivative of this g with respect to one of the coordinates. Expand this in a basis of the Lie algebra. So this means that this product here is I times something in the Lie algebra, and the coefficients in this expansion, they depend on the j and on the point x. But why is this possible? So is this object here, is this in the Lie algebra? Well, intuitively, maybe we would say if, let's say, g of 0 is the identity, then this one here is also just the identity, and here we take the derivative at of a curve at the identity, so we get something that's in the Lie algebra. If it's not in the Lie algebra, if g of 0 is not the identity, then we are at some other point here at g of x. So we get something that's in the tangent space at g of x. And by this g inverse, we transport this to the identity. So intuitively, we would expect something in the tangent space at the identity, and that would be in the Lie algebra. But does this really work? So let's just show that this intuition is correct. So if we define, let's say, h of x and t as g of x inverse, and then g of x plus t times ej. So with this ej here, that's supposed to be a canonical unit vector. So this means we take the jth argument here in this second function and replace xj by xj plus t, and we keep all the other x coordinates here. Now, this is a curve through our group, and if we go to t equals 0, then we have g of x inverse, g of x, so we have the identity. It's a curve through the identity. And if we choose arbitrary but fixed x here, then we can now look at, let's say, dh dt. But what's that? That means that we just take the derivative with respect to the jth coordinate here, because only in the jth coordinate we have the t. If we evaluate this at x and 0, then we get something that's really in the Lie algebra, or rather in, let's say, I times the Lie algebra with our convention. And what's this? Well, that's just g of x inverse dg dxj at x. So we can really expand this thing in a basis of the Lie algebra, and these coefficients here we will now use in order to define our Haar measure.